In this video, I'll be sharing with you how to answer questions for a secondary school topic, and that is sum and product of roots. My agenda for this video is to give you a brief intro on how sum and product of roots can be derived, and to give you one example on how sum and products of roots can be applied in an examination question. I'm sure you have seen this very familiar general quadratic equation. It states ax squared plus bx plus c equals to 0, where a, b, and c are your constants. Let me now introduce to you one more condition to this equation, and that is the roots of this equation are alpha and beta respectively. Let me tell you something. Using these two roots, I can actually derive back the same old equation ax squared plus bx plus c equals to 0. And let me show you how. Alpha and beta roots can actually be manipulated to form this equation x minus a multiplied by x minus beta. After expansion, we'll be left with this equation x squared minus x multiplied by alpha plus beta plus your constant alpha beta. Now, let's compare this equation with this equation. Take a few moments to think, what's the difference between these two equations? Now, do you notice that the coefficient of x squared is actually different? Well, in this equation, the x squared coefficient is a. However, in this equation, the coefficient of x squared is 1. So, how do we make them similar? Very simple. We divide this equation throughout by a, giving us this following equation. Now that the coefficient of x squared is similar, let us compare the coefficient of x and your constant term. Now, the coefficient of x in this equation is negative alpha plus beta. However, the coefficient of x in this equation is b over a. As a result, I can conclude the following: that alpha plus beta is actually similar to negative of b over a. Now, let's look at the constant term. In this equation, the constant term is alpha beta. However, in this equation, the constant term is c over a, leaving me to conclude on the following. Alpha beta is actually the same as c over a. Now, let me give you a summary of what is actually important in this derivation of roots. Summary: the sum of roots alpha plus beta is actually the same as the negative of the coefficient of x, which is b, divided by the coefficient of x squared, which is a. Next, the product of roots alpha beta is actually the same as constant term c divided by the coefficient of x squared, which is a. Now, these two results are actually very important, and you should actually memorize them or know how to derive them, because these two results are often being used in examinations on sum and product of roots. Now, let me show you how to apply these two results in an examination question. I'll give you this exam question. The equation 3x squared minus 2x plus 1 equals to 0 has roots alpha and beta. Now, let's break down this question. What are a, b, and c? The question didn't tell us, so let's define them on our own. Now, a is actually the coefficient of x squared, b, coefficient of x, and c, your constant term, leaving me to conclude on the following. A is 3, b negative 2, and c, your constant term, which is 1. Now, we can start on the question. The question wants us to find the sum and product of roots. Sum of roots is actually alpha plus beta. And how do we find that? We find that by taking negative of b over a. In this case, my b is actually negative 2 and my a is 3. As a result, my sum of roots, which is alpha plus beta, is actually 2/3. Now, let me find the next part of the question, which is product of roots. Product of roots is actually alpha beta. And if you recall correctly, it's actually c over a. In the question, my c is 1, my a is 3. As a result, my product of roots c over a is 1/3. Now, let's go on to the second part of this question. That is, find the value of alpha square plus beta square. Now, this is a very commonly misunderstood concept by students. They assume that alpha square plus beta square is actually the same as alpha plus beta square. However, this is wrong. Instead, alpha plus beta square is actually alpha square plus beta square plus 2 alpha beta. Now, let's notice this equation very closely. Do you see alpha square plus beta square inside? Let's observe other components of this equation. Have we already found alpha plus beta? Have we perhaps also found alpha beta? The answer is yes, in the previous part of this question. As a result, we can use the result to actually find alpha square plus beta square. After some simple manipulation, gives us the following. Alpha square plus beta square is actually equal to alpha plus beta square minus away 2 alpha beta. Now, we have found in the previous part of this question that alpha plus beta is actually 2/3, whereas alpha beta is actually 1/3. As a result, after some simple substitution, alpha square plus beta square is actually negative 2/9. Now, let's go on to the last part of this question. That is, to find the value of alpha cube plus beta cube. Okay, students often misunderstood alpha plus beta cube as alpha cube plus beta cube. However, this is also wrong. Instead, alpha cube plus beta cube is actually alpha plus beta multiplied by alpha square plus beta square minus away alpha beta. Now, let me ask you, have we found alpha plus beta? Have we also found alpha square plus beta square? And have we also found alpha beta? Yes, all the components of this equation have been found. As a result, we can just substitute in the relevant numbers, giving us negative 10/27, which is the value of alpha cube plus beta cube in this question. Now, in summary, let me summarize for you what we have been taught. Now, you must actually remember that alpha cube plus beta cube is actually alpha plus beta multiplied by alpha square plus beta square minus away alpha beta. Next, also remember that the alpha square plus beta square is actually not equals to alpha plus beta square. Instead, alpha plus beta square is actually equals to alpha square plus beta square plus an additional 2 alpha beta. Now, we have come to the end of this video. If you think that this video has actually helped you, please give us a like and also subscribe to this channel. If you still have any enquiries on this topic, do feel free to drop a comment in the comment box below. Thank you.